Hey everyone, in this video we're going to be talking about how to find the volume of a cylinder. So the first thing I want to do is I want to define what a cylinder is. So you can see here that I've put pictures of 3 different cylinders. And you'll notice that these are solid geometric figures, so they're 3-dimensional. And they have a base that is a circle, or a cross section that is a circle. So that means that if you were to slice this anywhere, you would see a cross section from the top down that would be circular. So here I'll shade a base on this. So you can see in red here there's a circle, here there's a circle, here there's a circle. It'll be the same way on the top and bottom. And these circular bases are connected by parallel lines, as you can see here in blue on the sides. So these cylinders are solid geometric figures with straight parallel sides and a circular base or cross section. Now, what I like to do is compare cylinders to a shape that we know pretty well, that you've learned about in previous math courses, and that's a rectangular prism. So let's go to a rectangular prism really quick. This is a rectangular prism. A rectangular prism has a base that is a rectangle. So I'll shade it here, a base that's a rectangle. And it's connected to its opposite base by perpendicular rectangles. Right? We can see that here on the outside, these perpendicular rectangles. Now, this is usually when we're talking about volume. So volume is a measure of how much material, how much quantity can fit inside of an object. It's a quantity of 3-dimensional space enclosed by a closed surface. So when we're thinking about volume, you can think of how much water fits in a cup. The cup would be that enclosed surface, and the amount of water would be that quantity of 3-dimensional space inside of it. So it's a measure of how much fits inside of something. And the first 3-dimensional figure that you learn in math to calculate the volume for is this rectangular prism. And so I hope when I say this that this sounds familiar to you, but when finding the volume of a rectangular prism, we multiply the length times the width times the height. Length times width times height. So your length and your width make up the base, and your height is the distance between the two bases. So we could say that volume is equal to length times width times height of this rectangular prism. Now, I'm sharing this with you as review. I hope it's review for you. If it isn't, and this is the first time that you're seeing this, this is how you find the volume of a rectangular prism. You find the area of the base, which is length times width. That's the area of a base. I'll color it again here in green. So your bases, there's a base on top and a base on bottom. With the way that this picture is written, I could draw in dotted lines to give you an idea of where the base is down here. I hope that you can visualize that. The length times the width is just the 2-dimensional area of the base. And then we multiply that 2-dimensional area of the base times the height. So this is just area of base times the height of the prism. Now, this is actually almost identical to how you find the volume of a cylinder. So in our last videos, we learned about the value pi, which is the circumference of a circle divided by its diameter. And you also learned about finding the area of a circle. And so you'll recall that the area of a circle, say area equals pi, this value, that's the ratio between the circumference and the diameter of a circle, times the radius of a circle, r, which is half of the diameter, half of the distance across the center of a circle, squared, right? Area equals pi r squared. This is how we find the area of a circle. And I'll label these, and again, I hope this is some review for you. So area is equal to pi times the radius squared. And recall what that means when you square something is that you're multiplying it by itself. So the area is equal to pi times the radius, right? It's multiplying by itself. Now, in a rectangular prism, we said that we're multiplying, when we do length times width times height, what we're really doing is we're multiplying the area of the base by the height. Well, we're going to do the exact same thing to find the volume of a cylinder. We're going to multiply, volume is going to be equal to the area of the base, right, times the height. It just so happens now, though, that our area of our base, instead of being a rectangle, it's a circle. And so our formula here, area equals pi r squared, we're going to take this pi r squared and plug it in front of the height here. So pi r squared times the height. So the volume of a cylinder is equal to pi r squared times height, or the area of the base times the height of the prism. So let me bring in a clean cylinder here, and we'll try one of these with some measurements. So here's a clean cylinder, and I want to start out by identifying where a radius would be. So if you think back to what you learned about the area of circles, if you were to find the center point, where I just put a blue dot here, the center point of a base on a cylinder, the center point of that circle, and you were to measure the distance out to the outside of the circle, the outside edge, that would be the radius, right? Or you could think of the radius as half of the distance across the entire circle. It's half of the diameter, right? The diameter would be this distance all the way across the circle. And so our radius is only half of that. I hope you're with me on that. So let's erase this and put our radius. Our radius, let's say, for example, that our radius on this cylinder is 5 centimeters. And what if we knew that our height on this cylinder was 20 centimeters? Well, to find the volume of this cylinder, we would then need to take our equation. Volume is equal to pi r squared times the height. And we're just going to plug these numbers in. So 5 being my radius, I plug in here, and 20 being my height, I'll plug in here. And so my equation now says volume is equal to pi times the radius 5 squared times the height 20. And now I've made a one variable equation. I'm just going to solve for v by executing the expression on this side. So for pi, I like to use the pi button on the calculator because remember, pi is an irrational number. It's a decimal that goes on and on forever but doesn't repeat. And so in order to get the most accurate estimation of this, if I use the pi button, it's going to give me many of those figures, many of those decimal points. If you don't have access to the pi button, you can use the approximation of 3.14. But if you have that pi button, let's use it. So I'm going to go ahead and start out with my exponent here, and I'm going to solve 5 squared. So I have now the volume is equal to pi times 5 squared, which is 25, times our height 20. Well, now I can just put this into the calculator. I'm going to use that pi button. So pi times 25 times 20, and I get the volume is equal to 1,570.79. So I'm going to round to 0.8. Our volume here is equal to 1,570.8 cubic centimeters. So our units here, I'll make my box a little bigger. Our units here are going to be centimeters cubed with a 3 above it, because we're talking about a 3-dimensional figure. So we're trying to figure out how many cubic centimeters, 1 centimeter by 1 centimeter by 1 centimeter, fit into this cylinder. Okay, so 1,570.8 cubic centimeters. Let's try another one. So we'll bring in another cylinder here. So here's another cylinder. We know that in order to find the volume, we need 2 different measures. We need the height and the radius. So let's say that what we're given here is a diameter, the distance across the center of this cylinder. And we know that the diameter is equal to 30 inches. So we have a 30-inch diameter here. Well, we know that the radius is half of the diameter. So we would have to divide this in half, divide it by 2, to get a radius of 15. Now, what if we also knew on this cylinder that our height was 52 inches? Okay, so we have a height this way of 52 inches. Well, we have enough information now to find the volume of our cylinder. We're going to use our equation volume is equal to pi r squared times the height. Remember, pi r squared is just the area of that circle. So I'm going to plug in the numbers that I do know. Volume is equal to pi. We know r is 15, so 15 squared times the height, which is 52. Now I'm going to start out by squaring 15. So 15 times 15 gives us 225. So volume equals pi times 225 times 52. Now I can just put that into my calculator, multiply pi times 225 times 52, and I use the pi button on this, and I calculate that the volume is equal to 36,756.63. I'll just leave that at 0.6. So we have found, this is going to be in cubic inches now. We have found the volume of this cylinder. Now you'll notice that in our formula for the volume of a cylinder, we have three different variables. We have the volume, V. Pi is a value, so that's not a variable. We have the radius, R, which we square, and we have the height. So our three different variables are the volume, the radius, and the height. If we know any two of these three, we have a one variable equation and we can find the other. So our first two examples that we did, I gave you the radius and I gave you the height, and so we were able to find that third value then, which is the volume. Now in the second one, I didn't really give you the radius, I gave you the diameter, but we know how to find the radius from the diameter. So we were able to use what we knew to determine two of these three values, and we could find the other. And so if we knew just a volume, knowing just one variable, if we knew V, could we find R and H? We wouldn't be able to because we only have one variable, and that would leave two different variables that could be anything. You can't solve a two-variable equation like that. So we would need to have then, if we had the volume, we would need to have either the radius or the height to find the other. So let's do an example like that where I'll give you the volume and I'll also give you either the radius or the height. So let's get some new space here. Here is a cylinder, and here's what we know about it. The cylinder has a volume of 3,024 cubic centimeters. And we also know that it has a height of 12 centimeters. What is it that we need to do to find the radius, which we don't know? So we want to know what is the radius of this cylinder that has a volume of 3,024 centimeters and a height of 12 centimeters. Well, let's use our equation that we know. We know that the volume is equal to the area of the base, pi r squared, times the height of the cylinder. So what pieces do we know? Well, we know the volume, so we can say 3,024 is equal to pi. Now we don't know the radius, so times the radius squared times the height. Well, we do know the height is 12. So we can see here now we have made a one variable equation. The only thing that we don't know is r, and so we're going to try to find the value for r. So to do that, we need to just solve this like a one variable equation. We're going to divide by 12 on this side to get that 12 to go away. Divide by 12. 3,024 divided by 12 is 252. So I now have 252 is equal to pi times the radius squared. Well, we know the value of pi, so to get r by itself, we'll have to divide both sides by pi to cancel pi out. So now I have the radius squared is equal to whatever 252 divided by pi is. And I'm going to put that into my calculator using the pi key, or if you don't have a pi key, you can do divided by 3.14, and I get roughly 80.2. Now, these are going to be long decimals because when we're using pi to multiply or divide, we're bringing in a never-ending, non-repeating decimal. And so you're going to get very messy looking numbers, and we'll round them. So now we don't know what r equals yet. We just know what r squared equals. We want to know what r is equal to. So the opposite of squaring a number would be to take the square root of the number. So we're going to, on both sides of the equation here, take the square root. The square root of r squared, just cancel each other out and we're left with r. And 80.2, if we take the square root of that, we get 8.95. So let's do 8.95. And again, this is a approximation because we are rounding. Actually, it's 8.955, so I could round this up to 8.96 as a final answer here. Well, let's think back to what our units were. We had centimeters cubed and centimeters. This radius is going to be in centimeters. So 8.96 centimeters will be our radius. Let's look at one more example like this, but this time I'll give you a radius and not a height, and I'll give you a volume. So let's get some space here, and we'll bring in a fresh cylinder. So here's our cylinder. Let's say that the information we had was that we had a radius of 6 inches and we have a volume of 230 cubic inches. And we want to find our height, which we don't know. So recall that we have an equation that is volume is equal to pi times the radius squared, which is the area of the base, and then we multiply that by the height. So we know a volume, so let's plug that in. 230 for our volume is equal to pi times the radius, which we also know is 6 squared times the height. I'm going to start by squaring 6, so 230 is equal to pi times 6 squared is 36, 6 times 6, so pi times 36 times the height. Well, now I can multiply these two numbers, pi times 36, so 230 is equal to, 230 is equal to pi times 36, which is 113.09. That's slightly rounded, but 113.09 times h. Well, to get h by itself, we need to divide by 113.09. That'll cancel out. If I do it to one side, I have to do it to the other, so 113.09. And when I do 230 divided by 113.09, I get an answer of h is equal to 2.03, or approximately 2.03. That's rounded to the nearest hundredth. And we were working with our units. These were inches, so our height would be 2.03 inches. This would be our height. So remember, anytime that you have two of these three variables, the volume, the radius, or the height, by using this equation, we can solve for the variable that we're missing. You always need to have two of them, two of the three. All right. As always, please make sure that you're reaching out and asking us questions if you have them or if you need support. And I will see you in the next video.